All right, we're going to talk about sets today, 2.1, and we've got three different types of sets that we're going to be talking about. The first one is called a description, which has to deal with words. So when we see a set like this containing the elements January, February, March, if we were to describe that set, this would be the set of months in the calendar year. Okay, so you want to be as specific as possible when you are talking about sets. Now, we've already defined previous sections, the set of natural numbers, and those are our counting numbers that go on infinitely, okay? So now we're going to talk about roster method, and the roster method is a list of items. And those items, another word for items is called elements. So if I was to ask you to list the set A of natural numbers less than 6. So remember, natural numbers means that we start with our counting number, 1. We have no fractions, we have no decimals. So if I were to write the set A, you'll have these braces, and then what you'll have to fill in is this box in your MyMathLab. So the counting numbers that are less than 6, which means not including 6, we would start at 1 and we would end at 5. Now, if it's a small list of numbers, we can go ahead and list them, separate them by commas. If it's a larger list of numbers, we can use the ellipses to say that it continues between numbers. So now we have the set B, natural numbers less than or equal to, so we call this is an inclusive set because it includes 45. So what they'll have is they'll have some boxes for you to fill out. They will have ellipses, which means that it's going to continue, and then they will have boxes to end with. So when I fill these in, the start of my set would be 1, 2, 3, and then I want to end with 45, and so I'd have 43, 44, and 45. Now, there are some sets in there which don't have to deal with numbers. I usually don't include those sets. You can look at that as an example, but I try to stick with the numbers. That's something that you're going to know, okay? All right, another symbol that we're going to need to know is this symbol right here, which looks like a big E, and it is an element of, that's what we read it, and it means that it's part of the set, okay? So if I have a set A, and I have the set numbers 2, 4, 6, and 8, I can say that 8 is an element of set A because it is in the set. What you have to be careful of is this right here. A set cannot be an element of another set. So if they put something like this, 8 in braces, that means it is the set 8, which is not an element of A, because A is the set 2, 4, 6, 8, and 8 is a set. So basically this right here would be a subset. So this would be a subset of A, not an element of A. And so if we went along back to this other one over here, we could say that 7 is not an element of A because it doesn't have membership in that group, okay? All right, the last type of set that we're going to look at is called set builder notation, sometimes called set generator notation. And this is read like this. The set, well, let's say, start over again. So we'll say D is the set of all x's, and that line right there is read such that a condition holds true. Okay, so we have to have some condition which determines whether the element is in the set or not. And so what they're always going to have is this information when you go into your MyMathLab. They're going to have B is equal, they're going to have braces, x such that x is a natural number, and then they're going to have a box for you to fill in the condition. Okay, so what you're really responsible for is filling in the condition. And so if you look at this set B, the numbers are between and including 7 and 14. So one way to write that is that you can say x is greater than or equal to 7 and x is less than or equal to 14. Okay? You may also write it like this, which we haven't really talked about compound inequalities, but either way is going to be a valid way of writing that relationship, okay? Now, when we go to the next one, we're going to have A is equal to the set of all x's such that x is a natural number, and then they're going to have a box for you to fill in the condition. And then the condition, this one, because we start with the number 1, we don't have to include it because all natural numbers start with 1. So we would just fill in that x has to be less than or equal to 9. Okay, we're going to focus mostly on the ones that have numbers. So I'm going to skip that next one, and I'm going to go to this next fundamental concept of sets, okay? So equal sets are two sets that have the exact same elements. Okay, so if we have set A having red, blue, and green, and we have set B as having green, red, and blue, they are equal because they have the same elements. Red, blue, and green, it doesn't say anything about order, but they are the exact same items in each of those sets. Now, this is something that you want to star. Cardinal number. Cardinal number is written like this, N of, and then the set letter. Okay? They're not going to say find the cardinal number. They're going to say N of A equals, and they're going to have a box. So cardinal number means the number of elements in a given set. So if I were to look at the set above, A, red, blue, green, the number of elements in that set is 3, and that's the cardinal number for that set, okay? Equivalent sets, which is different from equal sets, equivalent sets are two sets that have the same cardinal numbers, okay? So let's say that we'll call this set C is the set 1, 2, 3, 4. And we'll say that set D is the set cat, bird, dog, and fish. And C is equivalent to D because the cardinal number of C is 4, which is the cardinal number of D. Each one of those has 4 items in their set, but they are not exactly the same. So we say that they're equivalent, not equal, okay? And then the last one is the empty set, and the empty set sounds just like what it is. There are no elements. And it is written either with a big circle with a slash through it or 2 empty braces. It is not written like this, and I see a lot of students do that. Technically, there's something in the set, and it's that empty sign. And so we can't have that inside braces, okay? So we don't do this. It's either one or the other. And then the universal set is the big set containing smaller sets. And we'll look at that more when we get to 2.3, okay? So these examples right here, when I'm looking, when it says find the cardinality, it's not going to say find the cardinality. It's going to say this, N of A. And so when I see N of A, that means I want to count the number of items in A. So 1, 2, 3, 4, 5, 6. So the cardinal number is going to be 6. They could write it in set builder notation. And so N of B would be all the counting numbers or natural numbers that are less than 16. So if I start with 1 and I count all the way up but not including 16, there would be 15. Make sure for this one you don't put 32. The cardinal number of C is one element. There's one thing in that group. The cardinal number of, and we'll just call this set H, the cardinal number of H is 0 because there's nothing in that element, okay? The cardinal number of this set A is going to be 4. 1, 2, 3, 4. The cardinal number of this set B is going to be 12 because there's 12 months in a year. The cardinal number of G is going to be 1 because there's one word in that set and it's 3. This one's a trick question. The cardinal number of H, there are no elements that are natural numbers, that are counting numbers, that are also negative. So that would be 0. Okay, and then the last thing that you have to do on this set, on this information, is be able to define equal and equivalent sets. And so when I do equal and equivalent sets, I must do count each item. So if a set is equal, it is also equivalent. Okay. So, lion, tiger, monkey, lion. So, A equals B. A is equivalent to B. So, this one would be both. Okay. The next set, purple, green, yellow, has 3 items. And B is QRS, which also has 3 items. So, A is not equal, but it is equivalent to B. And then the last one, the first set A has 3 items, the second one has 4. They do have some overlap, but they're not inclusive, so this one would be neither. Okay? All right, that finishes 2.1.